Hello everyone. In this lecture, we are going to discuss one very important concept which has the application of probability a lot and which we have discussed in little discrete parts in our previous lecture, and it is coin toss. Now basically when we talk about coin toss, we talk about head or tail when we talk about a single toss. But then if I toss the coin twice, then the sample space increases. Then again, if the coin is tossed 3 times, the sample space will again increase. And so this means as I increase the number of coin tosses, the number of outcomes are going to increase. But do you think that there is a pattern here? Well, to study that pattern or to understand that pattern, we are going to discuss this particular concept, coin toss. So as I already told you that if we are tossing one coin, then upon tossing this one coin, we are going to get, the sample space as head or tails. At the same time, if we are tossing, two coins or basically one coin twice, then the sample space, it becomes heads, tails, heads, heads, tails, tails, and tails, head. Well, this is not the usual way of writing it. We always consider this heads, heads to be the first one because it makes our work a little easier. Then we write it as head, tail. Then we write it tail, head, and then we write it tail, tail. But it totally depends on you that how do you like to write it. Then again, if we are tossing 3 coins, then the sample points, as we have already seen in one of our previous lectures, it becomes head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head, and tail, tail, tail. So these basically are the 8 possible outcomes if we are tossing 3 coins together or if we are tossing one coin thrice. Now let us understand and let us study the pattern. So basically if I am tossing one coin, then the sample space, then the total number of elements which are there in the sample space is equal to 2. If we are tossing 2 coins, then it becomes 4. If we are tossing 3 coins, then the total number of outcomes become 8. Now do you find something familiar with the numbers 2, 4, 8? Well, 2 can actually be written as 2 raised to the power 1, 4 can be written as 2 raised to the power 2, and 8 can be written as 2 raised to the power 3. So this means that if I am tossing my coin one time, then the total number of outcomes which are related to that experiment is 2 raised to the power 1. That is, number of outcomes associated with that experiment raised to the power the number of times we have done that experiment. So again, if we are tossing the coin 2 times or if we are tossing 2 coins, then the sample space has 4 elements or 2 raised to the power 2 elements. So again, this 2 here is basically the number of outcomes which are associated with one experiment raised to the power the number of times. So the number of times that experiment has been performed. Then again, here also you can see that this 2 is depicting the heads and tails, and this 3 is depicting the number of times this experiment has been performed. So this means that if I continue this particular series and if I toss my coin, let's say first toss it for 4 times. So tossing 4 coins, I'm not going to write the sample space, and in fact I'm not going to bother with the huge number. We simply will calculate the total number of outcomes here, which we all know that they have to be 2 raised to the power 4, and that is 16. And thus if we are tossing the coin n particular times, then in n tosses we are going to get the sample space, the number of outcomes in the sample space is equal to 2 raised to the power n. Here this 2, as we have already discussed, is the outcomes which we are going to get upon tossing it one time, and this n is the number of times the same experiment has been performed. So number of times an experiment has been performed. And this is how we basically can find the total number of outcomes related to coin tosses. So let us now move on and see some interesting questions that we can solve on coin tosses using probability. The question reads, a coin has been tossed 4 times and we need to find the probability of getting at least 2 heads, at most 2 heads and exactly 2 heads. So here we know that since the coin has been tossed 4 times, so this means that the number of elements in the sample space here will be equal to 2 raised to the power 4, that is equal to 16. As if we are doing n tosses, then the number of outcomes are equal to 2 raised to the power n. And here since n is 4, so it is 2 raised to the power 4, that is 16. Now we can solve this question in either way. We can solve it by considering all the elements of the sample space, that is by writing down all the elements, or we can simply solve it by not considering them at all. So let us solve this question by both the methods. So by the first method, if I want to solve it, I'll have to list down all the elements of the sample space, which will be, well, let's say all 4 are heads, or basically 3 are head and 1 is tail. Now this tail can change its position. It can come on the 4th toss, or it can come on the 3rd toss and the remaining 3 tosses can be heads. Then it can be on the 2nd toss. It can be on the 1st toss as well. So these basically are all those sample points which are associated with 3 heads and 1 tail. Now we can have 2 heads and 2 tails as well. And considering all the possible arrangements, well, we can have head, tail, we can have head, tail, head, then we can have tail, head, tail, or tail, head, or we can also have tail, head. At the same time, we can also have 3 tails and 1 head. So this will be the same as in this particular case. So it can be 3 tails and 1 head on the last one, then 2 tails, head on the 3rd one, then a tail, then tail, head, tail, or head, tail. And for the last one, we can have 4 tails. Now considering all the sample points, all we need to consider now is identify the sample points in which we are getting at least 2 heads. So for that, let us see and let us count that how many are there. So basically we want to find the probability when the number of heads are greater than or equal to 2, because we know that here we have to find at least 2 heads, and at least 2 means 2 or more than 2. So this will be equal to n of h greater than 2 upon n of s, where n of s is already 16. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now you can see in these 10 and this one more, in these 11 sample points, we actually have the number of heads as greater than or equal to 2. So considering this particular thing, we can say that the probability that the number of heads is at least greater than or equal to, it is 11 upon 16, as the n of h greater than or equal to 2 from the sample space, it is 11 by 16. Now let us find the probability of h being less than or equal to 2. So for this, we'll have to consider the remaining sample points along with those sample points in which we have considered exactly 2 heads. So here we can say that this particular sample point will be included, this again, this, 5, and these 6 sample points in which we have 2 heads exactly. So I can say that probability of h less than or equal to 2 will also be equal to 11 upon 16. And for the last one, that is probability of head actually equal to 2, we can simply say that these 6 sample points right here, so 1, 2, 3, 4, 5 and 6. In these 6 sample points, we have exactly 2 heads, and thus the probability of h being equal to 2 is equal to 6 upon 16. And this is how we can solve this particular question when we know the sample space, or we can list down the elements of sample space. But my suggestion would be that we prefer the second method whenever the value of n, that is the number of tosses, is greater than or equal to 4. So since we are considering 4 here, so for 4 or more than 4, we are going to consider the second method, which we are going to discuss now. So for the first method, that is for the first particular value, which is probability of head is greater than or equal to 2, we can say that for this particular probability, we'll have to find out and add the probability when head is equal to 2, when head is equal to 3, and when head is equal to 4. Now considering each of these events as an independent event, we can say that this probability of head is equal to 4 is when we have 4 heads on the 4 tosses. Then probability of head is equal to 3 is when we have 3 heads and 1 tail. And probability of head is equal to 2 is when we have head tail and head tail. So basically we have 2 tails and 2 heads in this particular part. Now to find the probabilities associated with these possible events, we can say that here in this particular case, since the number of heads are 2 only, so out of the 4 tosses we want to select 2 heads on any of the 4 tosses. And since basically it is selection, so I can say it is 4C2 upon 16. So this means that out of all those 4 tosses, 2 tosses has been selected randomly, and on those 2 tosses, 2 heads has been put. So this means on the remaining 2 tosses, automatically these tails will go, and thus the probability associated with head is equal to 2 is 4C2 upon 16. In the same way, if I consider this head is equal to 3, then out of the 4 tosses, I want 3 tosses to be heads. So 4C3 means that out of the 4 tosses, I have selected 3 tosses, any 3 tosses, and I have put heads on them. So this means whatever slot is unfilled yet, that will be occupied with this by this tail. And this again will be divided by 16, which is the number of sample points associated with the random experiment. And here in the same way, it will become 4 by 16. Now if we consider the total probability here, it will be 4C2, that is 6 by 16, plus 4C3, that is 4 by 16, and at the same time it will be 1 by 16, thus giving us 11 upon 16. So this is how we can find the probability of getting at least 2 heads in 4 coin tosses. Now for the second part, that is for P of at most 2 heads, that is probability of getting at most 2 heads, it will actually be the same thing here, but the only change will be that the number of heads will be less than or equal to 2. So this means that I have to consider the probability when head is equal to 0, or when head is equal to 1, or when the value of head or the number of heads is equal to 2. Now if you look at these 2 cases carefully, then you will see that they are exactly similar to each other. And the reason is that if the number of heads is 4, then we are going to get 4 tails. If the number of heads is 1, then we are going to get 3 tails, and if the number of heads is 2, then we are going to get 2 heads, which we have already considered here. So this means that here I can consider t is equal to 4 situation, and if I will do the same calculation here as well, it will turn out to be 1 by 16. Then if I consider t as 3 here, that is tails as 3 here, so this will be 4C3 by 16, so 4 by 16, and if I consider 2 heads, so this is the same case in fact, so it will be 6 by 16, and this means the total number of outcomes will be 11 by 16. The total probability in fact of getting at most 2 heads is 11 by 16. And the third case in which we want the probability of heads or getting 2 heads, then this will be equal to, simply this particular case individually, so it will be 6 upon 16. So this means by this particular method, if we do one particular calculation, then taking that as a reference, we can find the other numbers quite easily. And so I'll definitely prefer this method over this, because after 4 tosses, it becomes more tedious, because to list down 2 raised to the power 5 or more tosses, it will be very difficult for us. With this, we have come to the end of our today's class. I hope you've understood this question and you've enjoyed this class as well. So in our next class, we are going to discuss another new concept, but until then, keep practicing and have fun. Goodbye.